Okay, ladies and gentlemen, I welcome all of you, the faculty delegates from all over the world, for this wonderful international webinar series on gastroenterology endorsed by American College of Gastroenterology. I am Dr. T.S. Chandrasekhar, a governor for American College of Gastroenterology India region, and a member of webinar subcommittee from the ACG. I bring warm greetings from World Gastroenterology Organization as a scientific committee member, and I also bring the warm greetings from Tamil Nadu Dr. MGR Medical University and my institution, Mid India Hospitals and Academy, Chennai. Webinar series saw the success of over 19,000 delegates checked in, logged in from all over the world. Then it really inspired us every month. Why can't we do the fourth series? I'm very glad to tell you that all the webinars have been endorsed by American College of Gastroenterology, which drew the attention of delegates from all over the world. And they gave the tag name the topic, the world experts are here, with the quotation that news, that is New Endo GE webinar series. And this webinar series was inaugurated by Professor Dr. Jonathan Lighton, President of American College of Gastroenterology, wherein we planned for 12 webinars scheduled from April 24 to March 25. You have to tell them well in advance a year for them to get all these webinars to get endorsed. And I'm very glad to inform you that we saw the participation of the Professor Dr. Barry Marshall, Nobel Prize winner, who is a discoverer of Helicobacter pylori. He gave the lecture on the journey of discovery of Helicobacter pylori, and further, it was attended by over 9,000 delegates from all over the world. Then there was no looking back for our webinar series because it drew the attention again to tell you that from all over the world. This webinar series is possible because of the cooperation and coordination from my colleagues Gokul, Satya, Yogesh and Prasad and Trinyana Sambandha. As I said, these 12 webinars, how we designed it is with the participation of the national faculty and international faculty. You name any stalwarts who have done the original work, they are here. And it was ably supported by the luminaries from our country and outside the country, from USA also, as moderators and panelists. It is very difficult for me to go through every name as moderator and only thing I can tell you the topics we had. Type 2 diabetes mellitus with diabetes and GI tract, systemic hypertension and portal hypertension, and dyslipidemia and fat and liver, pharmacotherapy of obesity, endoscopy and surgical management of obesity, doctor and law, doctor and ethics, doctor and research grants, and doctor and finance, and doctor and entrepreneurship. And we had a part 1 research methodology, how to choose a research question by Ramakrishna, and choosing the most appropriate study design by Dr. Dr. Sarup Datta. And the research methodology part is going to happen today, how to analyze the data by Dr. Usha Datta, and manuscript writing and publication by Dr. A.C. Anand. And the next the webinar will be in January 29th, Master Checkup in Gastroenterology and Pre-Cancer Lesion in Gastroenterology, Screening Methodology and Management. And 11th webinar in this series is we are going to have live endoscopy workshop on 20, 21st, 22nd of February. And the last but not the least in March is going to be a debate on endoscopy versus surgical management in gray areas in gastroenterology. I welcome you all to this in-person live workshop meeting going to be held on 20th and 21st and 22nd of February. There we are going to have a PGYG course, postgraduate and young gastroenterologist course, and a new addition stalwarts lecture session and master videos dedicated session on enhanced endoscopy and medical surgical topics in gray areas and contemporary issues in gastroenterology. And it has been endorsed by American College of Gastroenterology, other societies too. So this series is going to have very important topic on manuscript writing and publication, and research methodology part will be how to analyze the data. We have two eminent speakers. The first talk, there's a small change. Professor A.C. Anand will be talking on publications, the manuscript writing and publication. I've seen Dr. Anand giving his talk very nicely. I was so impressed, and it is a great honor to listen to him. Equally, Dr. Bushra Datta, who has been running the research methodology course, and this is my pleasant task to introduce the faculty now. Professor Anand is a professor and head department of gastroenterology, Kalinga Institute of Medical Sciences, Bhubaneswar. He was the honorary president of Indian Society of Gastroenterology. I think I took over from him as the president of Indian Society of Gastroenterology. He was the honorary president of Indian Association for the Study of Liver. He served as the Director General Medical Services, Navy, President's Honorary Surgeon and Chief Consultant Gastroenterology, Armed Forces and Medical Surgeon. And he is also very much into research methodology. He's got several publications to his credit, and the H index, you know that, over 37. This will be moderated by Dr. Nalini Gupta, the President GA Associate, Wisconsin, USA, Clinical Adjunct Professor of Medicine, University of Wisconsin School of Medicine, is the governor of American College of Gastroenterology, like me, Wisconsin chapter, counselor, governing board of American Society of GI Endoscopy, and he has got research interests vary from biliary, pancreatic, and therapeutic endoscopy, and honorary distinguished educator award and master endoscopy award from the ASGE, and he has also several publications to his credit. The second speaker will be Professor Usha Datta, Professor, Head Department of Gastroenterology from my alma mater, PGI Chandigarh, recognized for her contribution to understanding epidemiology and management of gallbladder cancer. You know that gallbladder cancer is very rampant in the northern part of India, unlike southern part of India. And clinical and research interests include, apart from gallbladder cancer, gallstone, IBD, and GI emergency. The Professor Rakesh Tandon Award for Best Mentor Award, CM Habibullah Oration Award, and she also has got over 47 publications to her credit. Dr. Anjana Mohan, Dr. Anjana Ranjit Mohan, looking at her H index, I thought she's old, but looking at her, the chronological age is very young. She is the managing director and consultant diabetologist, Dr. Mohan's Diabetes Specialty Center, and president, Madras Diabetic Research Foundation, Chennai, adjunct faculty, Department of Medical Sciences and Technology, IIT Madras, Sakuntala Amir Chand Prize for Young Scientist, ICMR, Tamil Nadu Young Scientist Award, Government of Tamil Nadu, and she has got over, my God, over 830 publications, H index of 89. She is the illustrious daughter of another illustrious diabetologist, Dr. Mohan. We have panelists, Dr. Haribhakti Sebadas, who is the professor and head Department of Gastroenterology, SCB Medical College, and Hospital, Cuttack, Orissa, and Dr. G.S. Lamba from New Delhi, Sri Balaji Action Medical Institute, and Arvind Kumar Singh from Uttarakhand. Now, these webinars became very popular and we had very good attendance from all over the world because of our national ambassadors and international ambassadors like Chaubal, Pravir Roy, and the J.R. Mahapatra, Girish Kumar, Nirmal Singh, and it is Arvind Gopi, and the international ambassador from USA, Malaysia, Nepal, and Bangladesh. And everyone had taken the honorary ambassador post and they spread the message of this webinar. Now it's my pleasant task of introducing the concept of this webinar and the faculty over. Now may I request Dr. Nalini Guda, have you joined in? Dr. Nalini Guda? Dr. Nalini? Dr. Nalini, you are there? Nalini, we welcome you. And the Dr. Anand talk is going to be first, so may I request you to moderate the session. You may introduce the topic and invite the speaker. Over to you, Dr. Nalini.
Thank you, Dr. Chandrasekhar, for this kind invitation. And it is great to see so many here right immediately after the ISG meeting. Only Dr. TSC can pull this off 2 days after. I hope everybody is home and with all the airline mess. I just got back home last night and wouldn't have joined if it's not for Dr. TSC's meeting. It is my pleasure to introduce Dr. A.C. Anand. Dr. T.S. has already given a brief introduction, and in the interest of time, I'm not going to repeat everything he has said. And as clinical gastroenterologists and those of us who have interest in clinical research, I think it's very important to ask the right question and to pick the right topic to do the study. So for that, I think knowing research methodology is important. And when you have finished your study, it's equally important to present your data. So writing the manuscript and presenting is more important than your study. So it's phase one is coming with the concept and doing the study. Phase two is equally important and more frustrating because somebody has to like your baby. So it's just not you saying, how wonderful your baby is. Other people have to recognize. And more importantly, I think the greatest satisfaction, as Dr. Chandrasekhar is showing all the H indexes, is that somebody has to cite your paper. That means that's the next level you have to go through. So whenever you conceive a research study, I think these are important. And I think we have an eminent gastroenterologist and researcher, Dr. A.C. Anand, who's going to walk us through the concepts of manuscript writing and publication. It's not an easy task. It's a journey. And hopefully he can shed more light into this.
While Dr. Anand coming, the format is back to back. We'll have both the lectures, then we'll go for the question answer session.
Can I share my screen?
Yeah, please.
Can you see it?
Yeah, fantastic. You are very familiar with the Zoom.
Okay. Thank you very much. And I'm a great admirer of all the faculty that you've mentioned. And it's a great honor to be part of this great program. This lecture was supposed to be after Dr. Usha Datta had harvested the data and analyzed it. And my job was to converting that data into global impact. But Usha will be speaking later, and therefore the topic is how to write and publish the manuscript. I would begin by saying that science is not finished until it is communicated. And in India, at least, you will remember most of your DM and MD or even DNB candidates who have done a thesis have not published their thesis. The publication rate of the postgraduate and postdoctoral thesis in India is just about 20 to 25%. Rest 75% theses are never published. And this talk was actually designed for those people. So I'll be going at a very basic level. And let me tell you first, why bother to publish your work? First thing is whether you are working in a government hospital or in a corporate hospital, career acceleration and differentiation from an average crowd is important. And contributing to science is the second main reason. That is, you add a brick to the wall and leave a legacy. Then establishing credibility and authority in the academic world is another reason why you should publish. And you get a peer review validation, and you can build a brand like Dr. Chandrasekhar has done and Dr. Nalini Guda has done. And of course, Dr. Anjana has done. And then finally, networking and collaboration opportunities swell up once you publish a good quality paper. A good quality paper is a magnet for collaborators, and you'll always be invited to conference to speak about your work, and you can possibly get easily the funding for your next project. Why most people are unable to publish their DM thesis is because they consider it a daunting task. They feel that peak is very high and the path is riddled with a lot of obstructions, and some of them may be unsurmountable. But let me tell you, a journey to 1,000 miles starts with a single step. And you must have heard the talk in the academic circles that you should either publish or perish. The publication which will help you in surviving is the quality publication. The quality of your paper you write is dependent on the quality of work that you have done. If somebody has dumped garbage on your table, you can't create a great paper out of it. Remember, publish or perish race. Publishing rubbish will not get you anywhere. A good quality paper increases your citation, H-index, and opportunities. And therefore, my slogan is publish and flourish, and publish good quality work. Nothing in life is to be feared, it's only to be understood. That is what Mary Curie said. And the data that you have analyzed, Yusha will be analyzing it little after my talk. Data is just a noise. A paper is the signal that you send to the world. And how do you write a paper? This is what I have described here is a narrative arc. You should narrate the story of your research in form of a sequence or in form of a story. First, you introduce the villain of the story, that is the problem that you have tried to solve, and this is what the introduction is about. Then you describe your weapons, that is your approach, and this is described in methods. Describe the battle that you have gone through and what has happened after that. These are your results. And finally, your victory, that is the impact of results, and discussion is the part of that. Initial draft is called the vomit draft. That means draft. That is, whatever comes to your mind, just write it down. Ernest Hemingway said that do not edit as you write, just get it down. Perfectionism is the enemy of done, and the first draft of anything that is not suitable for pronunciation in this talk. The thing is that if you start editing along the way, you may never finish the draft. And therefore, first draft is a rough draft, and you should try to finish it as quickly as possible. And after that, you should make your figures and graphs. If your figures tell a clear story, the text simply will fill in the blanks. Arrange your data visually. Worth 1,000 words. What a paper usually uses is either figure or graphs or a table. So a table, all three of them are supposed to be complete paper in itself. For example, this table I've taken out from one of the papers, and it shows a legend which describes what this table is actually trying to show. And then it shows a header row which is governing all the columns. And it shows the first column which is governing all the rows. And then you have a body of the table which is giving the real data. And then you give some explanation in the footnotes, And you also give all the abbreviations that you have used. So this is how the table will be constructed, and anything missing out of it will not be a complete table. Similarly, you also label the figures. Figure will have a legend, that is translocation of metabolites in the gut-liver axis. And if you want to explain the sequence in which the audience should read the points, you can mark the table as 1, 2, 3, 4, 5, 6, and give that explanation in the legend. And similarly, footnote will contain comments, abbreviations, and acknowledgements which have to be given along with the figure. Graphs, many people prefer very jazzy looking graphs, 3D graphs, but they are not very suitable for publication. Simple graphs, and rather using very colorful graphs. There are many journals which publish only black and white graphs, and you can use a pattern to fill in the figures, and the simple graphs are much better preferred. Then there are some regulation figures which have to be given. For example, the trial design has to be shown, and this is shown like this on the left side. And the consort diagram for a randomized controlled trial has to be given, and this is given on the right side. And we'll talk about the conventions a little later. This is the overall structure of a research paper. That is IMRAD, that is I is for introduction, which says why you have carried out this study. And this draws from the work done by others. That is a very brief review of literature and identifies the gap in knowledge that you're trying to fill. M stands for methods. Can someone duplicate your research after reading your paper? That is what is important. And the methods must contain PICO for the interventional study and PECO for the observational study. That is patients, intervention, comparator, and the outcome measures. Then results. What did you find? The R stands for results. It should be easily comprehensible format. Relevant data, additional data as supplementary material can be also given. And finally is D. R and A is interrupted by a small a, which means and D, and discussion. And the discussion implications are, what are the implications of the results that you found? Does it support or refute the hypothesis that you started with? What are the strengths and limitations and implications of practice in the future? Normally they say that paper represents an hourglass structure, as is shown here on the left lower side, because the introduction carries from what the work has been done outside, beyond your study, and from there you have found the gaps in the knowledge, and then you describe your study, and they find finally the implications for all the work that is being done outside, and that's why they call it an hourglass side. So let's look at it a little more details and giving you a few small things which are added extra. When you start writing, the two things are already ready. One is the introduction, because these two things were part of your proposal for the research. Why the study matters, that is what is usually given in introduction. Funnel approach, that is you quickly view at the global and then regional levels and see what is the gap in knowledge. And then you describe your aim as to what you are planning to do in this particular paper. Avoid a literature review dump here, so that introduction should be short and crisp. And then you describe methods which you've already written before the study started. How did you do it? It should be a reproducible science. Where did you do it? Mention the approvals that have been done and the statistics software that you've used. Include participant flow diagram and check stroke, consort, and care guidelines as to how to create these regulation charts. After that, you describe your results. Show the data clearly, use tables, figures, and in the text, don't repeat everything which is given in tables, but you report the main findings and report the effect sizes, confidence intervals, and p-values. And with this data, please make sure that you don't try to be flashy and descriptive. The results should only be presented here without any interpretation. And then you come to discussion. where you start interpreting your data, but don't repeat what you have already written in the results. What did we learn from this study? How does it compare to the literature and hypothesis? What are the strengths and honest limitations of this study? And later, you include a summary of take-home message in the conclusions. After that, you write the references, and the references usually follow the journal that you've selected, and we'll talk about it a little later. After having done this, then come the two most important part, that is writing an abstract, which is a mini paper in itself. It is one paragraph of about 250 words, which should be written in the last, and it follows the IMR-SEEK format, that is introduction, methods, results, and conclusions, and include data, not promises here. And finally, you draft the title of your paper. What is it about? It should be brief, informative, readily searchable, and include precise searchable keywords. And I'll give you one example of this, which has been published recently. And lastly, acknowledgements and certificates required. We will be talking about it also again. Now, you must have gone to a bookstore to buy a book and picked up a book to read only by looking at the title of the book. And similarly, you must have seen very jazzy posters of a Hollywood movie or a blockbuster, but you were put off by the title of the movie that has been given. So it is equally important, like a book, what you have an interesting title. And also on the back of the book, a paragraph is given, and that is what your abstract should be like to entice people into reading your paper. This is title should be, as I mentioned, brief, informative, searchable keywords, and it use it as a hook for the patient, for the reader to go through it. So this is one example of the title that I have chosen, recently published, Fecal Microbiota Transplantation Efficacy in Severe Alcoholic Hepatitis Unresponsive to Steroids, a randomized controlled trial. So look at this, what this title is showing. Title is showing in 12 words the intervention that have been done, the patients that have been used, and the comparator which is there, and finally outcome measures that have been seen. It's a very brief one, 12 words, concise, to the point, avoiding unnecessary jargon or phrases like a study investigating. It is informative, clearly states the intervention that has been done and the primary outcome being measured. And searchable keywords have been used. And these are highly specific terms. Researchers and clinicians would be searching in the PubMed or databases. And what is the hook in this? Unresponsive to steroid. This signals that the paper addresses a challenging, unresolved clinical problem, grabbing the attention of practitioners dealing with difficult cases. And you must realize, once you have written a paper and published it, what are the people going to see in that published paper? Title will be seen by all of them, and therefore that is the most important part of your paper. Abstract will be read by about 70% people, and about 50% people will look at the figures that you have drawn. Paper will be read only about 20 to 25% people will read the full paper. The abstract, therefore, should be informative with key results and clear conclusions. And looking at the figure, table, or graph, the message should be very clear. And I told you all the components that should be there in the table. It should be a complete paper in itself. Once you have prepared the vomit draft, you start improving and modifying the draft till it is perfect. In our time, we used to do it with a paper and pencil, but nowadays you do it with the track changes mode. It's important that you simplify the expressions and look at the journal's requirement, colleague treatment, and let it simmer and redo 2-3 times till you feel it is perfect. The writing style, if you are looking at, kindly make it very reader friendly. There are 3 rules. Clarity, that is, use simple sentences and not the complicated ones. Conciseness should be there, that is, remove the fillers which we usually use in our actual conversation, like actual, very, in fact, and using hyperboles. The coherence should be there. There should be a logical flow. Therefore, you replace utilize with use and avoid passive voice excess use. Data were analyzed is not the way to express it. And the professional tip is write like you speak to a smart colleague. On the right side, there is a cartoon in which a person has used a very flowery language, presumably something like what Shashi Tharoor does. But basically, what he's trying to say is Happy Diwali. There are several tools to help you in this. And these tools will be one reference manager, that is Zotero and Mendeley are free, EndNote is on payment. But if you're a student, buy EndNote now because it will be almost half the price. And then you have to do a plagiarism check by Authenticate. Equator network of guidelines. I'll show you that website. And you can use Grammarly-like tools to help you correct your grammar. But don't over trust AI. I'll be talking about this again later. AI may change the sense of what you want to say, and therefore you should trust your own feeling. On the right side, it shows that you have to be original in your paper. Don't just Control C is not really research. If somebody has done something and you are trying to do the same thing, is not considered research. This is the Bible for all people who are wishing to publish papers. That is, International Committee of Medical Journal Editors have given several guidelines regarding how the paper should be written and what all disclosures should be given. And this is a website you should keep handy and keep revising what is written there. And I mentioned about the Equator network, which gives the reporting guidelines for all the type of studies. Randomized trials, there are consort guidelines. Observational study, there are stroke guidelines. Systematic reviews, there are PRISMA guidelines. And see, all the 695 reporting guidelines are there. And you can do a search as to what your study is like, and you can look at the details of what guidelines are there to draft that manuscript. About authorship also, ICJME has given very clear guidelines that to be included as an author, the collaborator must meet all the four of following criteria: that he must have made a substantial contribution to the conception or design of the work or acquisition, analysis, or interpretation of data. He should have drafted the work or helped in revising it critically for important final approval of the version to be published has to be approved by everyone, and the agreement to be accountable for all aspects of work, ensuring accuracy and integrity, has to be included. If you meet all those four criteria, you are entitled to be an author, otherwise not. There are some more essentials. I mentioned earlier also plagiarism check before submission, because many a times there are some expressions which are very common and they tend to come in and they have already been published in that form. And this is what the people say, that I don't know from where these uncited sources have come from when the plagiarism check report comes. And therefore it is important to do a check before submitting the manuscript. Also, another suggestion is that you should avoid splitting the research into 2 or 3 papers. Try to give the complete research in one paper. And you should not try to submit your paper in more than one journal simultaneously. These days, there is a network which detects such duplicate submission, and all the 3 places, it will be immediately rejected. Transparency in data presentation is very important. All declarations must be very clear and transparent. Trial registration must be mentioned. Remember that integrity is doing the right thing when no one is watching, and your credibility is more important than your publication list. There are some additional requirements for most of the journals, and they are the certificates, statements, or declarations, and they include credit authorship statement, funding declaration, conflict of interest, ethical clearances, trial registration number, acknowledgement, and supplementary data, and that should also be included with the manuscript. A word about choosing the right journal. This used to be a very difficult task earlier, but now it has become very simple because most of the publication houses have their website which says finding the right journal for your research. And there you have to submit either your abstract or your keywords or aim or the title of the paper. I would suggest not submit your abstract because your data should not be submitted to any AI forum, because AI forums tend to learn from the data that is provided to it, and therefore it may utilize it at some other place. If you have already placed your manuscript at a non-peer reviewed site for everyone to know, then of course you can add your abstract. And to find out what AI does with this information, I picked up one paper from which has been recently published, and the title was Markedly Low Prevalence of Fatty Livers Despite Obesity in Prader-Willi Syndrome, a Search for a Protective Genetic Marker. So I asked the AI to look at which journal should I publish it in. So look at what the AI is doing. It is shown as thinking there, and it says that I'm thinking through the core theme of the paper described in the abstract to guide my journal recommendation. The research site at critical intersection of four disciplines, that is hepatology, which deals with MASLD, metabolism and endocrinology, which deals with obesity, human genetics, which talks about SNV analysis, and translation medicine, that is implications for the non-syndromic obesity. And this is how you have to look at the theme of your paper and then start categorizing the journal options which are available and which journal is fitting with your theme best. That is the journal you should start listing out. And it has done mapping top tier journals, and it's synthesizing the core themes of the journal as well as the core theme of the paper, and you find the best fit. And then AI is finalizing the recommendation, and it is confirming the journal relevance, that journal is really relevant, identify the best translation fit, and finalizing the title. It has given me four suggestions. First suggestion is I should write in cell metabolism. Impact factor is 30. Secondary is nature metabolism, if it is about the endocrine aspect you want to highlight, or hepatology journal if you want to highlight the MASLD aspect. And this is a decision that you have to take. What kind of audience are you looking for your paper? And this is how you choose the journal that you're going to submit your paper. We all wish that there was a Tinder for selection of journals where you could right swipe or left swipe depending on whether you like or dislike. But basic rules are the scope alignment is very important, and it is more important than the impact factor of the journal. Readership relevance is very important, whether you want the clinicians to read your paper or the basic scientists to read your paper. You have also to look at the acceptance rate of the paper and the peer review time that is taken by the paper, and clearly go through the author guidelines, what kind of font they prefer, what is the reference style is there, what kind of other ethical requirements they are asking for. You should avoid predatory journals which take money to publish a paper and promise a 48-hour acceptance, because all these journals do not have much value in the academic circles. Having written the paper completely, you then draft a forwarding letter. This is also equally important for an editor, which has to see about 20-30 papers in 1 hour time. And therefore, in your forwarding letter, you emphasize why your paper is best fit for that journal. What is the emphasize on the novelty, rigor, and the importance of your work. Explain in simple language using minimalistic approach. An editor has to read possibly 20 papers before he sleeps, and therefore, if You convince him by one paragraph as to why his journal should accept your paper. First battle is won. If you can't explain it simply, you don't understand it well enough. This is what Einstein said. And for writing a paper and submitting it for publication, all you require is meticulousness and sincerity. No brilliance is required in this. Most journals today I also ask for a graphic abstract. And it should be a simple graphics, highlight the methods and main findings, do not clutter it with details, use appealing colors, minimalistic design, and follow the journal guidelines in preparing it. And I have at random picked up one abstract, a graphic abstract here, and I'll show you what it is showing. It is showing the title of the paper. It is showing the hypothesis that it started with. It is showing the patients that it has worked on. It is showing the methods that it has used. It is showing the intervention that has been done. And it is showing the comparators which are there. And finally, it is showing the outcome which is measured and the conclusions that are shown in the paper. So all the important things are shown in the graphic abstract. One small figure which shows the complete paper in nutshell. A word about handling reviewers. Reviewers are not enemies. They are unpaid consultants trying to improve your work. Winston Churchill had said that criticism may not be agreeable, but it is necessary. It fulfills the same function and pain does in the human body. So therefore, even if unpleasant reviews are there, very seriously you should examine them and try to answer all the questions that have been raised. How do you respond to reviewers? Peer review is not for acceptance or rejection, it is to improve the paper. Don't take they want to help you improve the paper. Use a point-by-point response and stay polite even if the reviewer has not been very polite. Stand your ground. If you disagree with the reviewer, provide evidence but politely. Good to start with, we thank the reviewers for their valuable suggestion. However, so and so your whatever disagreement is there with the reviewer. A good paper usually becomes excellent after review. What is the editor's perspective on papers? That is, let me tell you, common reasons for rejection are that there is a scope mismatch. This leads to immediate rejection. The methods are weak, it will hurt the credibility of the paper and it will may be rejected. If you have tried to over-interpret your data, it will be punished and may even be rejected. Underpowered studies are never liked by the journals. Unclear endpoints, low quality figures, all these can be reasons for rejections, but there is no need to be despair if the rejection is there. This is not end of the road, because Einstein's papers were also rejected. Lancet rejects 90% of papers, and my own journal, Journal of Clinical and Experimental Hepatology, we accept only 1 in 4 papers. Important thing is to revise the paper as per the comments given and submit it to the next suitable journal. Remember, a rejection is just a redirection of paper. It does not mean that the paper has been a failure. For example, look at this man who has got so many rejection letters, but he says that I have not failed. I have just found 1,000 ways that will not work. And these famous words are from Thomas Edison, who had a lot of failures in his experiments. I have been asked many times, can I use AI to write a paper? ICJME has given very clear guidelines on this, and these are the 4 important portions of that guideline. First is the accountability remains with the humans, and the responsibility of accuracy will be with you, because AI is known to be inaccurate in vast majority of cases. Transparency and full disclosure. Wherever you have used AI, you have to make a declaration that I have used AI at so and so place. And last thing is academic integrity, that the research has been properly carried out and presented the way it has been done. And some of the minor AI use is generally ignored. For example, if you use spell check in your Word or Grammarly in your basic translation, and the work is, these are the things which are exempted. But remember, AI can change the meaning of your sentences, and therefore you should take responsibility of what is being sent. A Nature study has shown that about 14% of the biomedical abstract text is AI generated. And therefore, there are some cardinal rules to be followed. AI is an excellent friend to brainstorm with by deep research. It can give you the gaps in knowledge, review of literature, but generally it is older review because recent papers are not included in most of the AI platforms. It can help you in searching references. It can summarize the papers for you. Do verify the output of AI. It can hallucinate and confabulate. And remember, it does not usually cover last few months or years data. AI cannot collect your data for you. For meta-analysis, now there are specialized softwares which also need to assess the papers yourself for the bias and the methods. AI can't draw conclusions for you. If it does, you need to check if it is really correct or not. AI can improve readability of your text, but do not use AI to write the text de novo. Can editors find out if the paper is AI created or AI generated? The short answer is yes. There are softwares available which can immediately tell that it is generated by AI. Where AI is useful, where you can use AI and it will be very useful, used to prepare different formats of your paper on social media. You can draft main points for posting on X. You can plan a post for Facebook to highlight the main contribution of your paper. A short video can be prepared with the help of AI to highlight main points you make in the paper. Social media can make your paper, you can take your paper to audience at large. And does it increase citations? An observational study published in cardiovascular journals reported that Twitter promotion was associated with 40% higher citation rate independent of the article type. This is my penultimate slide, where I like to say that every paper is a building block of medical knowledge, a piece of jigsaw puzzle. What you publish could change how a patient is treated. The faintest ink is mightier than the strongest memory, and therefore all the research you have done should be published. Sit down to write today. Write your first draft this week, which will never be perfect. It is because it is just written, and revisit after a gap of few days to perfect it. To my take-home messages, writing and publishing requires meticulousness, sincerity, and patience. Academic brilliance is not required here, which is required in planning your study. Steps include selecting a suitable journal, following an author guideline, and presenting your research in simple and clear manner. Remember, every journal is waiting for good quality papers or good quality research, which has been presented well. And use the power of social media once your paper is published to popularize your work. And my last slide shows the path to success would be research meticulously, write clearly, and publish proudly. Thank you very much for your attention.
Thank you, Dr. Anand. That was a really good talk, even for people who have been doing this, that summarized it extremely well. I've learned a lot even listening to you after doing this a few times. As you said, it's a process, it's a journey. I think one should embrace it and enjoy it. I have a suggestion to your additions. I think the AI software like BioRender is also useful if somebody is doing basic science work and want to show like the receptors and how they are bound to, for clinicians, it's not that useful. I think it's a valuable tool to draw those things.
As Dr. Nalini said, yes, BioRender is very useful. but it is important that you acknowledge it in your paper that the diagrams have been prepared with the help of biorender.
Nalini, you will agree with me that Dr. Anand has made it a very fantastic presentation. Even people who are not interested in publishing, they would be interested. I like that last slide, sit down to write today. That is a caption. Really, I am now sitting down to write today itself some paper. I think the second thing I liked is academic brilliance is not necessary. That is necessary only when planning. But when start writing it, and the first slide I really liked it. When the flow comes, keep writing it. Don't stop it. Don't edit it, and it never ends. So fantastic! One of the best the lecture I ever had. I think we will take up question. Dr. Nalini also would agree with me. So you stay with us. Then I will hand over the mic to Dr. Anjana to introduce the topic and invite the speaker. Dr. Usha has been introduced already, and stay with us the rest of. Okay, Dr. Anjana,
Thank you.
please.
Thank you very much, Chandrasekhar sir. That was an outstanding lecture, Anand sir. Really amazing. Request to share your slides, please, so that we can share with others and students and stuff like that. That was really, really outstanding.
I've already shared with Dr. TSC.
Okay, right. We'll get it from him. So, Chandrasekhar sir, thank you so much for having me here today. I'm in a group of gastroenterologists. I think that is a first for me, usually being in the diabetes, endocrine, metabolic medicine circles. Thank you so much. This is such a useful webinar, and research is becoming the most important thing. As we know, most of metabolic disease and other things are in low and middle income countries, but we have the least amount of research coming out. So more and more people clinicians taking this up has become really, really important. So webinars like these, I was very impressed to see the entire series that you had displayed early on, and the very eminent and accomplished speakers, going through this whole thing. Dr. Usha Datta has already been introduced. So I would now ask ma'am to talk about research methodology, how to analyze data.
Thank you so much. Are my slides visible?
Yeah,
Yes, but you could make them into presentation mode.
I'll just do that. Just give me a second.
you go to the bottom and the.
Yes, perfect.
Yeah,
Perfect.
perfect.
Okay, so is there a slide which is being shown on the top also?
No.
No, you are perfect. Only thing your face is seen. That's all. We can also make it little. Okay.
No, you can.
Right. You want to hide all the things?
Perfect.
Okay.
Okay. Thank you so much, Dr. Chandrasekhar, for inviting me here. Thank you, Dr. Anjana, for your kind introduction. My job is to teach approach to statistical test, a practical guide for clinicians. It's difficult to compress it in half an hour, and also to follow Dr. A.C. Anand, who's a wonderful speaker. With this topic, it's not very easy for me. I'll do my best. So essentially, biostatistics means that you are having a population, say, of all diabetics in the universe, and you are drawing a sample which is representative, random, and adequate to get to your small sample size, which you are going to be studying and observing in detail and analysis. And then you're going to describe them. What is the mean, standard deviation, median, with the interquartile range and count. So this is our basic baseline table, which is just describing the data. And once you do that, you are going to now interpret and say that in my study population of 100 patients with diabetes, I found that this drug works. But now I'm telling the whole world that please go ahead and prescribe this same medication for all the patients in the universe. So that is how you're trying from your 100 patients to benefit humanity by asking everybody to extrapolate what you learned from your 100 patients. And that extrapolation part is called inferential statistics. That is confidence interval, standard error of mean. So all that uses probability theorem. So this is all is the statistics that we are going to talk about today. There are going to be no formulas, no numbers. All that we are going to focus is on just principles which are guiding our analysis. So we have descriptive statistics, which is describing the data, inferential statistics, which is telling us about how to infer for the whole population from your small sample size. So what we are trying to see is, in any study, it is the relationship between exposure and outcome. What is exposure? It could be smoking causing lung cancer. You're following up smokers and finding that they are having lung cancer, or you're looking at patients who are having lung cancer and finding out how many of them were smoking, or you're giving tofacitinib in patients with ulcerative colitis and seeing how many of them go into remission. Remission rates of 40%, 60%, 20%, whatever is your remission rate. You're looking at radiation injury and looking at birth defects. And you may be giving oral protein supplements in pregnant women and seeing whether there is improvement in the fetal well-being, or you may be giving oral protein and seeing whether the serum albumin is going up in patients with cirrhosis. So all that we are trying to study in any study is the relationship between the exposure and the outcome. A, is there any relationship? B, what is the strength of the relationship? So I'm going to take a very simple design. Exposure is obesity. Outcome is triglycerides. So we are going to look at patients who are obese and seeing whether they are going to have high triglyceride levels. So our study objective was to study the association between obesity and triglyceride. Second is the patients will also be having cholesterol levels. So we want to see whether with increased triglyceride, the cholesterol also goes up or not, and vice versa. Then you want to give a medication to see whether there's a reduction in the triglyceride level with drug A compared to drug B. So this is a very simple design I have taken. Now this is a clinical scenario. So our study question is obesity associated with increased triglyceride level? That is our study question. So always whenever you plan a study, you have to formulate your study question. The next step is our hypothesis. Our hypothesis in our mind is that obesity is associated with high triglyceride level. Third is that the statisticians put it this way, that is called the null hypothesis. They say that no, we are very conservative. There is no relationship between obesity and triglyceride. It is just a figment of your imagination. So the statistician first start with a no. That is the null hypothesis, that there is no relationship. Now the onus is on you to prove that there is a relationship. And the relationship can be obesity may be associated with higher triglyceride value or lower triglyceride value. And that is why we say a two-sided test. That before we do the study, we do not know whether obesity will have higher or lower triglyceride. So we are, having a very wide spectrum. And that is the alternate hypothesis. So we started with the study question, then we wrote out our hypothesis. We felt it will go in this direction. The statisticians say, no, there's no relationship. You then say, no, it may be higher or lower. So you have kept the field open. So before in any match between, say, India and Pakistan, you may have, any one of them could have won. You may want India to win. So that's a separate issue altogether. But the fact is that, so you wanting India to win is your hypothesis, but the alternate hypothesis is that any one of them could have won it. So in the study design, we have 100 patients who are obese. We have 100 patients who are overweight, and we have 100 non-obese, non-overweight people with a normal BMI. All that we are going to do is take their weight, triglyceride, cholesterol, and whether they have a fatty liver on ultrasound. This is a standard design. And then you're going to give drug A or drug B, do a randomized control trial, and reassess the same parameters after 4 weeks. Now, this is the baseline data. Say this is your thesis student who has collected this data. You have 100 obese, 100 overweight, and 100 controls. You can see that the weight here is higher. This is the mean weight, and it is indicated here mean plus minus standard deviation. Notice that the standard deviation is very small. And then the overweight people are having a weight of 80, and the controls are in the range of 50 plus minus 10. Now, if you look at the triglyceride, you just are doing an eyeballing of the data. Triglycerides are way high in this group and virtually normal in this group. And in the overweight, it is in between. Cholesterol again seems to be higher in this group and more or less similar in these two groups. And fatty liver is more often in the obese group. Then overweight is 40% and 10% in the control group. And the grade of fatty liver, that means very severe grade is higher here. So this is grade 0, grade 1. I'm just making it hypothetical that we have more patients in the most severe category in the obese group, whereas we have very little in the severe category and the moderate categories as we go down here. So this is the data your student comes to you with, and you want to analyze it. And we have drug A versus drug B for 4 weeks in all these groups. And this is the post-treatment data. You gave the drug. In the obese people, the weight from 100 came to 90. In the overweight, it came from 80 to 70. And here it remained more or less similar. The triglyceride levels have dropped. The overweight triglycerides have also dropped. Cholesterol level seems to have dropped. The fatty liver has come down from 70% to 40%. And the grades have also improved. So now I'm going to tell how to analyze this data. It's a very simple data. We'll just see how to analyze. Before that, we have to ask 5 questions. What are the 5 questions? First question is, what is the type of variable that we are looking at? Second is, what is the size of the data? Are there less than 30 members in the group or more than 30? Is the data normally distributed or not? Is there one group, 2 groups, or more than 2 groups? And are the samples related in any way? Like in this patient, in this, we will see in this data set how to go over these 5 questions. So what are the variables? So there are variables. First, you have to identify the type of variable. Now you see it can be a category or it can be a number. So a person can belong to Punjab, Haryana, Uttar Pradesh. So that is a category. Person can have a weight which is 50 kg, 60 kg, 70 kg. That's a number. Waist circumference is a number. A person is of grade A fatty liver, grade B, grade C, grade D. That is again a category. So here, category can be yes, no, that is male or female. Can be more than 2 categories, like Punjab, Haryana, Uttar Pradesh, or an order, like grade 1 mama, grade 2, grade 3, grade 4, grade 5, grade 6. So that is an increasing order. Socioeconomic status is an increasing order. So that is called an ordinal variable. The other number can be a continuous number, like weight of a person, height of a person, or it could be a discrete number. Discrete number is number of children in the family. It can't be 3.5. It can't be 4.5. It has to be either 3 or 4. But a continuous number can be 50.5 kg, can be 60.78 kg. It is all decimals are allowed. So when decimals are not allowed, then it is a discrete number. When decimals are allowed, it is a continuous number. So this is example, obesity, yes, no. So you see a person is either a red ball or a green ball. Second is city of residence. It can be Chandigarh, Ludhiana, Jalandhar, or Amritsar. It can be grade of fatty liver, that is 1, 2, 3, 4, 5. You can see it is the same color with increasing color shade to it. It can be height, weight, which is measurable as a number and decimals are allowed. And it can be number of patients with high triglycerides. So it can't be 48.5%, 5 patients are having high triglyceride. It has to be either 48 patients or 49 patients. When decimals, it is different, but as a number, the number of patients in your study has to be 101, can be 102, but cannot be 100.5. So these are discrete numbers. So that is the first thing which we have sorted out. We looked at a variable and decided, is it a category? Is it a number? And if it is a category, does it have two categories, more than two categories? And does it have an order to it? And for a number, whether it is a discrete number or a continuous number. All these things are important when we decide what statistical test we are going to apply. How many groups? Now it's very clear. Here we have three groups: obese, overweight, and normal. But if you want, you could club the obese and overweight into one group. So then it becomes obese and overweight versus normal. So then it can become a two group, or it can become a three group design. So here we are going to look at all these components. So we know that three groups can be obese, overweight, or normal. Two groups is obese or overweight, obese and overweight in one group. Within one group, if you want to study the triglyceride versus cholesterol in the obese group, it is within that group you're looking at one variable versus the other. So that is a one group analysis. The third question is, what is the data size? Is it less than 30, more than 30, more than 100? So this is essentially what we are trying to say. So we have more than 100, that means the robust data, large number of samples. Usually they are normally distributed and we use the Z statistics for that. 30 to 100, we check if it is normal, we use the T statistics. If it is not normal, then we use that statistics which we use for non-parametric distribution. That means the Mann-Whitney U test. So that is where we see here. So if it is a small sample and the less than 30 or the data is skewed, we use the U test, that is the Mann-Whitney U test. So large, robust data, we use the Z statistics. We use the thing as a normal distribution. 30 to 100, we use T distribution, that is the student T test. And if it is less than 30, it is better to use the Mann-Whitney U test. The fourth question, is the variable which we are seeing normally distributed or not? How do we do that? Is very, very simple. You have to just go into SPSS or any program, put the data, it will tell you it's normally distributed or not. So the simple way is to do a histogram. You will see that it is a bell-shaped curve, and this bell-shaped curve is laser pointer option. So this bell-shaped curve is telling us that in the center is the peak amount of data and very little data on both the sides. So this is normally distributed. We can also do what we call as a PP plot or the QQ plot. If the dots are on the line, that means your data is normally distributed. There is a test called the Kolmogorov-Smirnov test. It's a Russian test. Shaparovil test, again a Russian test. All these, if it is more than p-value of more than 0.05, it tells you that it is normally distributed. So it's very simple. We don't base it on just one parameter. We use 2 or 3 of these tests. If 2 or 3 are showing us that it is more or less normal, we take it as normal. If 2 or 3 are showing more that it is like skewed data, we take it as a skewed test. And all statistical programs give it very easily. Now, why we use this 30 is the T distribution. You see, this blue graph is the Z distribution. This is what happens when we use the bone mineral density stuff. We use the Z score. And the T is, the graph is more or less very similar to the Z score. But if you see, if the data is less than 30, it becomes like a flat thing. Then you cannot use the statistical assumptions of a T test. So that means if your sample is less than 30, please don't use a T test. So as I said, if your data is less than 30, we are going to use Mann-Whitney U test and represent it as a median with interquartile range and use a box plot. But if your data is normally distributed, which is large data, 1,000 patients, 2,000 patients, all these are large data, and these are physiological parameters like blood pressure, heart rate, all these will be normally distributed, and we'll represent it as mean plus minus standard deviation and use a student t-test. The fifth key question is, are the samples related or unrelated? That means, suppose I'm using eye drops in the right eye and the left eye, both the eyes are related to each other. So it is very important to make one as a control for the other. So ophthalmologists can easily make, in their randomized control trials, can use one eye versus the other. And before and after in the same patient, you give a hypertensive drug, antihypertensive drug, blood pressure before, blood pressure after, same person. So they are related samples. And twins, again, they are related. If you have chosen a particular control for a particular case, then they are also related analysis. Unrelated is if you have just taken 50 obese patients and 50 non-obese patients and you're looking at the triglyceride, the obese group is not related to the non-obese group. So this is an unrelated analysis. Okay. So which test? So this is the most important which people want to know. And this is based on very simple things. And I have a chart at the end. You can just take a screenshot of that. Use that chart to decide which test you're going to apply. So don't waste your time trying to understand which test I should apply. Just I'm going to take you through the principles and I'll give you a chart at the end of the day with which you can choose which test you want to apply. So obese versus high triglyceride level, you see, obese people, you want to look at the triglyceride, high, those with high triglyceride versus low triglyceride. It's the standard 2x2 table, and we use the chi-square test. But if you have a smaller sample size, we use the Fisher exact test. And if you're looking at one versus the other related, then we use a McNamara test. That means I just told you about twins, about right eye, left eye. So improved, not improved. So you give, on the right eye, you give a medicine and you say, okay, this patient improved. And on the left eye, didn't improve. So we then look at the number of pairs of improved, 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 not improved, not improved, improved, and not improved, not improved. So you get 4 such category, and that you can assess by the McNamara test. For 3 groups also it is chi-square. So let's take a very simple example. Obese 100 patients, controls 100 patients. High triglyceride are seen in 70 of these 100 patients and normal triglyceride in 30. Controls, again, it is 10 in the high triglyceride group and in the normal group, it is 90. So it's a simple AD divided by BC. You know that 70 and 90 divided by 10 into 30 is going to be a big number. Bigger the number, more likely your test is going to be significant. So this is the simple chi-square test. So just quickly, what is happening behind the scenes? Here we are having 3 groups. So this is also chi-square test. This is 3 into 2 table. 3 into 2 table. So again, it's a chi-square test. Now we will just see how do we get this p-value thing? So here we are having 100 patients in the control group, total 200 people. So if there is going to be no relationship between obesity and high triglyceride, the statistician says there should be 50-50-50-50 in each group. So that is what the statistician wants to start with by saying null hypothesis, there is no relationship. So there should be equal distribution, 50 here, 50 here, 50 here, 50 here. So that's what the statistician tells us. But we find that no, there were 55 year and 45 year and 45 year and 50 years. So there's some difference which is happening. But if you analyze, the p-value is only 0.01573, which means it is not less than 0.05. That means it is not significant. That means 15% chance that it could have happened randomly. So p-value tells us that we want the random chance of such a result to be less than 5%. That is what p-value tells us. P-value of less than 0.05. If you convert it into percentage, it's just very simple. It says the chance that you've got this result has happened just randomly is less than 5%. So there must be some reason which is, some relationship between obesity and triglyceride. Okay, so this thing could have happened even randomly, 55, 45, 45, 55. You can just shrug and say, oh, it could have just happened. So that is what you don't want when you want to prove a hypothesis. Now I have changed the numbers 60, 40, 45, 55. Now you see there is a 3.7% chance that it could have happened randomly. So less than 5% chance, so p-value is 0.03. So now we start saying, oh, there is something happening between obesity and high triglyceride. We take it further 60, 40, 35, 65. Now you see the p-value is 0.004. Say, oh God, this is less than 1% chance that it has happened by random distribution. There has to be a relationship between obesity and triglyceride. So here the relationship is saying association and not causation. Now, so here we say that 80, 20, 20, 80. Now the likelihood is less than 0.5%. So 5%. So then there is definitely a likely association. So what are we doing? We are observing more than what the statistician expected. He expected 50, 50, 50, 50, but we found 70, 30, 10, 90. So we are observing something different than what the statistician expected. The more our data is different than what he had expected, the more likely we will say, you are wrong about the null hypothesis. Our hypothesis stands. And that is why we say that our study has shown significant data. So p-value of less than 0.25, we reject the null hypothesis, which says that it's all equal everywhere. And then we say obesity is associated with high triglyceride. Association does not mean causation. That's a separate thing altogether. I would suggest please read the Bradford-Hill criteria. It's a very well-written monologue on that. Now, how do we represent the same thing? We use a bar graph, 70, 30, 10, 90, obese control, look at your y-axis, and we are observing more than what you expected in this group and very less in this group. So how do we report it? The obese group more often have high triglyceride levels than the control group. So we write that as percentage so that we can compare across by percentage, and always write the numerator, denominator, so that we know whether the study was done in 10 people, 100 people, 1,000 people, a million people. So that adds to your credibility, and that increases the inferential statistics, which is totally dependent on your sample size. Describing binomial variables, all of you would have seen the slice of pizza. So a slice of pizza is the event of interest. That means high triglyceride level. And this is normal triglyceride. So size of pizza by the remainder of the pizza is what we are going to be talking about. And so the event of interest is high triglyceride level. And this is those who did not have high triglyceride level. So this is high triglyceride. So this is in the obese group, how many people had high triglyceride. So, and in the non-obese group, how many had triglyceride. So what is odds? It is the slice of the pizza divided by the remainder of the pizza is odds. Whereas risk is slice of the pizza divided by the whole pizza is risk. So from this, we'll be calculating the odds ratios and the risk ratios. So in obese group, we found that a larger number of people had high triglycerides. And in the normal group, we had a smaller number of people who had high triglycerides. Even in this, there were some people who had high triglyceride, but it is smaller than here. So the slice of pizza is larger here. Slice of pizza is smaller here. Excuse me. In risk ratio, it's the slice of pizza divided by the whole pizza. And here it is slice of pizza by the whole pizza. So this is this entity divided by this entity is our risk ratio. This entity divided by this entity is our odds ratio. So for example, if I say 40 divided by 60 divided by 10 divided by 90. So that is our odds ratio. Whereas 40 divided by 100 divided by 10 divided by 100 is our risk ratio. So usually relative risk, if it is 1, that means there is no protection or no risk. But as you go towards higher and higher, it becomes bigger and bigger risk. Usually anything more than 5 is considered as a big risk, 2 to 5 is moderate risk. Whereas on this side, we usually indicate protection. And you can notice that it is only from 0 to 1, and here it is 1 to infinity. So 0.5 is equivalent to 2. So that means this is giving protection about 2 times more here, 5 times more protection. So as this number becomes smaller, there's more protection. This is just a convention when we say this. So number needed to treat, risk in the drug arm minus risk in the control arm. So suppose our response in the drug arm was 80%, that is 0.8, 80 by 100 is 0.8. And response in the placebo is 30%, so that is 30 by 100 is 0.3. So what is the difference? 0.8 minus 0.3, that is 0.5. 1 divided by this number, risk difference, is our number needed to treat, which is 1 divided by 0.5, that is 2. So what it is actually meaning, you have to treat 2 patients to expect 1 extra response in your drug group compared to the control group. So that means there's a very good number needed to treat. If you treat 2 people, you will get 1 person who will be getting a response. Smaller the number needed to treat, the intervention is more efficacious. If I have to treat 100 people to get 1 additional response, then that means that is not a very great intervention. So continuous variables, we wanted to look at whether the triglyceride and the cholesterol are associated in some way, that is correlation. If we find that increasing age is associated with increasing blood pressure, that is regression. So we are trying to say the increasing age is affecting the incidence of hypertension, so that is regression. And it agrees with each other. That means I use a blood sugar by finger method and I use a lab method. If both the values agree with each other, we use the Bland-Altman plot. So here, increased weight associated with increased cholesterol. We want to say increasing weight, increasing cholesterol. Both of them are continuous variables. Both of them are normally distributed. You see the standard deviations are small. And we use Pearson correlation. So here I have done it in SPSS. The Pearson correlation is 0.526, which means a good correlation. And it is p-value significant 0.001. So this is a cholesterol and triglycerides are related to each other, and with increase in one, the other one is also increasing. So this is positive number. So increase in one is associated with increase on the other. In a negative correlation, increase in one is associated with decrease in the other. So this is what this graph tells us. Increase in the x-axis associated increase in y, increase cholesterol, increase your triglyceride. Now this one is showing low positive correlation. That means just like how increase OT is SGOT is associated with increase SGPT, whereas a low association could be with increasing age. There may not be always an increase in blood pressure, though there's a trend towards that. Or something like there is no correlation between 2 things at all. One thing is not affecting the other. And here it's a negative correlation. So increase in one is associated with decrease in the other. So here it is like increasing age is associated with decreased fitness level. So that will be a negative correlation. So here we have obesity, and we are looking at weight, cholesterol, and triglyceride. And you can see that the triglyceride is skewed. There's a very large standard deviation. So here we have to use Spearman rho. Spearman rho, because one of the variable is showing a very skewed distribution. That means a non-parametric distribution. That means it is not normal. That means it has a very wide standard deviation. And when we want to say that the weight, with increasing weight, there is increasing cholesterol. Here we want to show the effect of weight on cholesterol. So we use a linear regression statistics. The question here is, does increase in weight result in increase in cholesterol? And does increase in weight result in high triglycerides? So here we are saying not just triglyceride levels. Here we are saying high versus low triglyceride. And the cutoff we have taken is as 200. And that is the time when we use logistic regression. That means yes and no. A predictor variable or outcome variable is yes, no. So that is where we use logistic regression. And as I said, kappa, when one radiologist is saying fatty liver, another one is not saying fatty liver. So then how often do they agree with each other? That we use kappa statistics. And as I said earlier, blood sugar in one lab versus the other, triglyceride in one lab versus the other, both of them are numbers. Here we are looking at the agreement with the Bland-Altman plot. So in summary, if an increase in weight is associated with increase in cholesterol, we use Pearson correlation. If you are saying increase in cholesterol is associated with increase in triglyceride, because triglyceride was a skewed distribution, we use a Spearman correlation. If increase in weight is associated with increase in triglyceride, we say that there is a linear regression, because here we are saying the weight is increasing the triglyceride. Here we are just saying there is association, just two things are by chance linked, but they are, one is not causing the other. Here we are saying that the weight is causing the increased triglyceride. Now, if we say increase in weight is associated with hypertriglyceridemia, that means here we are saying high, low. So then it is yes and no, so it becomes a logistic regression. And when one radiologist says fatty liver, does it agree with the other? That is kappa statistics. Yes and yes, no, yes, no. Fatty liver, yes, fatty liver, no. Does one lab's triglyceride agree with the other lab's triglyceride? That is called the Bland-Altman plot. So when we look at obesity versus triglyceride, skewed distribution, and here, as I told you earlier on, it is student T, and for which the skewed distribution, we use the Mann-Whitney U. When we have related data, we use the paired T, and the equivalent one is the Wilcoxon sign rank test. And for three groups, it is ANOVA, and its equivalent one for skewed is Kruskal-Wallis test. So I will not go into too much of all this detail. It will confuse. All that I want to say here is controls, you can see their cholesterol is at a lower level. In the obese group, the cholesterol is at higher level. You've plotted both the histograms. It looks wide apart. Most probably it is significantly different, and that is why their things are wide apart. So these two cholesterol values are coming from a completely different patient population, and that is why we say that the t-test is significant. So that is essentially what this is saying. In the control group, you're having it here. In the obese group, your triglycerides are here. So this is coming from a different population. This is different population. So we are saying the population of obese and the non-obese are different. And that is what we are trying to infer from that. So here we can see that the triglycerides in the obese group, the mean levels of serum triglyceride was significantly higher among the obese than the non-obese. So you can mention the exact values and you put the p-value and you put it as a graph. This is how we represent the statistical analysis. Do not torture the data till it confesses, which is very commonly happening. So if you just go on asking something, some p-value will come up, but that may not be the right way to go ahead. So which statistical test, as I said, this is the slide you need to just take, and you can take a screenshot of the same. I will minimize this for you. Just 1 second.
This is perfect, Dr. Usha.
Perfect.
The
Okay.
size is perfect. Perfect.
Okay, so you can just take a screenshot on this, and I will just move this away, and so that you can take a screenshot. You can take it and keep it in your computer and refer to it whenever you want. You look at the outcome variable, whether it was continuous, categorical, or survival, and then you see your exposure variable, what it was, and you can just work through this chart. Okay, very good. And so the 5 simple tests to summarize your hypothesis, you should have a pre-specified plan. You should say, okay, obesity is associated with increased triglycerides. Organize your data into an Excel and a statistical program. I like to use SPSS, which I've been using for last 25 years now. Check the status about these 5 things we discussed. Is there one group, 2 groups, or 3 groups? 2 groups was our obese and overweight in one side and normal on the other. 3 groups were obese, overweight, and normal. Then you see whether your data is normally distributed or skewed distribution. The size is 30, less than 30, 30 to 100, more than 100. what is your variable? Is it a category or is it a number? And whether it is related or not related. Apply the test, look at that thing which I showed you, that chart, interpret the test as p-value less than 0.05 or not less than 0.05, and then you present your data as text and graph. So the ground rules are: do not torture the data till you get a p-value of less than 0.05. Post hoc analysis, that means you saw some data and on that basis you are generating a hypothesis. It is not testing your hypothesis. Your testing was obesity is associated with increased triglyceride. That was your hypothesis. And if that thing is substantiated, that means you have proven your hypothesis. In between, when you see the data, some new association keeps coming up. That is called post hoc analysis. That is exploratory and not confirmatory. Subgroup analysis you can do. You can specify up to 7 subgroup analysis, but they have to be pre-specified. Dr. Gordon Gayath has a very good article on subgroup analysis. And if you do too many tests, you're going to increase the alpha error. And that is all I have. Thank you so much.
Anjana, unmute yourself.
I'm so sorry. Ma'am, that was such a complicated thing made so simple. Can you still not hear me? It's unmuted now.
Please
Yeah.
unmute yourself.
Can you hear me?
It's unmuted. Yeah.
Yeah. Ma'am, people take years to understand this, and in like half an hour, everything is so beautifully summarized. I think that last chart was just superb. So thank you, ma'am. That was really, really good. Sir, do we now take some questions?
Yeah. And the hypothesis is statistics cannot be learned with one lecture. So what is the null hypothesis?
That's what you just said.
And what
I think she disproved it. She just disproved it, right?
And what is the alternate hypothesis?
What she just heard lecture.
Anyhow, this will be a really nightmare for anyone who has not understood anything and who is stepping into the statistics or the kind of research methodology. But you simplified it. Both the lectures are marvelous. Usha, you put in a lot of effort. That last slide is going to be on the desktop of many of the delegates watching from all over the world. I think we will start with Dr. Nalini's question to Dr. Anand, then Anjana, then we have panelist Dr. Hari Bhakti is there. Dr. Hari, you can come on the screen. Okay, we'll start with Dr. Nalini. Nalini, I must thank you very much for this coming from, just coming from Amritsar and have jet lag and you are here. That shows your commitment to ACG. Girish, if you have any question, Hari, first we'll start with one round. 2 moderators and the panel. We'll start with Nalini, then Anjana, then Hari Bhakti, then Girish. Okay, we'll start like this now. Yes, you are now.
So thanks, Dr. Chandrasekhar. I'm here only because of you. You're very persuasive, so I could not say no to your invitation.
Thank you.
No, this is indeed a very important series. Nobody wants to listen how to resect one more polyp. I think it's important that they learn this because that's the key, right? How well you do is displayed in the clinical research we do. Dr. Anand, you've given a great summary of everything you've done. In my own limited experience, I think as you rightly summarized in the slide by Thomas Edison, that it's not a failure, but it's actually a feedback from the reviewers as an opportunity to improve your studies. And sometimes when the review comes back, you look at it in a different angle and a paper improves and you submit it to a higher impact journal. Would you like to comment on that?
Definitely. The reviewers, I look at reviewers as I said, unpaid consultants who are trying to improve your paper. And if you think that after those reviews and after correcting the points that they've taken, you you need to put at a higher impact factor journal. It is up to you. But if the reviewers have pointed out, done a hard work, I think some loyalty should be there for the same journal, and the paper should probably go to the same journal.
Yeah.
So it just happens in scientific things. You send it to some journal, and then the reviews come back, and you go back and reanalyze the data, and the paper actually becomes much stronger because now you had two of your peers who are better in the area who have come back and commented on it. I do agree with and the likelihood that you'll get accepted in the same journal is higher because it's probably the same reviewers reviewing again.
I think, Ananda, you rightly mentioned rejection is not failure. Rejection is to improvise and improve your thing. And I think Dr. Nalini also trying to say that. And I like that word, reviewers are unpaid people to improve your status.
What
Sir, namaskar, sir. Can I ask one question only?
Okay.
Hello.
Now
sir,
Anjana's turn. I'll come back to you, Grace, 1 minute. Dr. Anjana, yours.
Yeah. So
Thank you,
my
Nalini.
question. My question to ma'am is that I have a number of questions from the audience actually, and many of them you have already covered. They're primarily asking questions like which test for which study, which you beautifully covered. So not going into that, but there are two important things that I thought maybe you could cover. Lot of confusion between what is confounding versus what is bias. So people are a little confused between the two. That's one. Second is they want to know, are there any online courses or something where they can learn the stats in an easy way?
So confounding versus bias. Confounding is, suppose I take a group of asbestos worker and I'm looking at lung cancer. And my hypothesis is that asbestos increases incidence of lung cancer, which is known that, okay, asbestos can set up carcinogenesis. But I find that these asbestos workers are also smokers. If I did not take the history of smoking in my proforma, and I just say that asbestos increases lung cancer by 5 times, 10 times, or whatever, but there is something behind the screen, that is smoking, maybe alcohol, maybe indoor pollution, maybe any of the other things which could also cause lung cancer. So, an asbestos mine worker is more likely to be also a smoker, and smoking is also related to the outcome, that is lung cancer. So, confounder is something which is related to the exposure and related to the outcome. So this was happening even in the classical study on CA pancreas and coffee drinking. Coffee drinkers were supposed to be at increased risk for CA pancreas. Now this did not ring a correct bell because they did not note down that coffee drinkers were also smokers. And actually behind the screen, it was the smokers which was increasing the risk for cancer, and it was not the coffee drinking. So confounders are things which are behind the screen. They are like the ventriloquists who are doing the job, but they're not visible to you. And bias is, suppose I have a treatment group where I'm giving a new treatment like tips, and the other group I am doing conservative management. And my hypothesis is that the tips group will do better than the control group. When I want to measure certain outcomes, which are especially, non-quantitative, it's not just the, say, the bilirubin or the albumin or something like that. It is something of quality of life or some parameter or hepatic encephalopathy. So these are things are all subjective ways of assessment. The way I will assess in the group which is getting the intervention and the way I will assess in the group which is not getting the intervention, there may be a little inherent bias because the person who's conducting the study at a subconscious level wants to prove his hypothesis, because everybody is human. So that is why, to make it very clear, we have a pre-specified outcome. We have the outcome being assessed by an independent person in a pre-specified way. And that is why we do a randomized control trial. That means you're not putting the good patient into one arm and the bad patient into the other. So to minimize all these biases, we do various statistical things like randomized control trial, having the outcome pre-specified, having the outcome as a measurable outcome, having the outcome, the person who's measuring the outcome should not know whether the patient received an intervention or did not receive an intervention. So that is why we have placebos which are similar looking. All these things are done to prevent bias creeping into your study.
Thank you. Thank you. I think you made it very clear, confounding and the bias is very clear. Dr. Hari Bhakti, then Dr. Greece. Hari, you have a question too?
Good evening, everyone. There are certain questions from the audience. Actually, what should be the sample size to take a study? Usha, madam, please. And there is a question that how many samples are required to publish a pilot study?
This is to Dr. Anand. Okay. So first
No,
question
to
to
Dr. Usha,
Usha.
madam.
Okay, right.
The first part I will take. The second part will be with Dr. Anand because he's the publisher today. The editor today. So regarding the sample size, it is a completely full topic. It needs minimum half an hour, 1 hour to teach that.
You will be given 2 minutes.
So
okay.
the softwares go to that. There is one software called N. There is a software called Epi Tools that is from the WHO. So there are several softwares, online sample size calculator. Put what you want to put. It will keep giving you prompts and it will tell you, okay, this is your sample size. And whenever you have to choose, you have to choose an alpha error of 5%. We have to choose a beta error of, means a power of 80%. I tend to use a power of 90% so that I can cover more than one objective in a better way. And I calculate sample size for all the 3 objectives and choose the higher one for the study. So, and apart from, suppose I get a sample size of 80 and I know that there may be 5-10% dropout. So I usually would take it to a rounded off figure of say 100. Or if I find that in a randomized control trial, the dropout rates may be higher, or in a cohort study, it may be higher, I may increase my sample size accordingly so that I retain the power, even if there are a few dropouts or technical issues.
But you said in one of the slides, minimum 30 should be there for the even distribution.
Yes, so minimum 30 to use the t-test.
Yeah.
Less than the t-test. So it's become a kind of a thumb rule, 30 patients minimum in each. But that is not for the study question. So suppose my study question.
But is there a relation? Is there a relation between the occurrence of the disease and the sample size? Like if the disease occurrence is less and the sample size needs to be more, or like that, it's not there?
Yeah, it is there, but suppose there is disease is not so prevalent, so you can't have a very large sample size because your study will not be feasible. So then it may be your underpowered kind of a study. So depending on the effect size, depending on how much difference you're expecting in the treatment arm versus the placebo arm, suppose you're finding a 20% chance of reduction in blood pressure. So then you will need a larger sample size. Suppose I want to look at 40% reduction, then I may need a smaller sample size. The smaller the difference I'm trying to look at, the larger the sample size I will need.
Okay, Dr. Anand.
I think Usha has already answered that question. Anything which is less than the expected power and alpha error and beta error would be a pilot study. And to get the pilot study to have minimum interpretive results, you need a bare minimum of number. That is definitely there. You can't have a study of two patients on one side and one patient on another side. So it should be a respectable number. But anything less than what you have planned to do by calculating sample size would be a pilot study. And what you pointed out was there are some rare studies which are rare diseases where there is a problem, and there will always be a conflict between the scientific rigor and the practicability of those papers. But there are some strategies people are using, and it is being accepted by the journals, and it is also being accepted by the regulatory authorities. And there is a journal called Orphanet Journal of Rare Diseases, which has carried out several reviews on this, that how do we carry out good studies with very small sample size of rare diseases. One of the methods is to use composite or surrogate outcomes. For example, you don't use the patient outcome as improved or not improved. You can work on the symptom score in a patient. How has symptom score changed over 12 weeks? In that case, you can have more interpretation with a smaller number of people. Similarly, you can reduce the noise and variability in the study by tighter controls, and consistent measurement will help a lot. For example, you can mention that same imaging machine was used, or the same lab method was used, or the centralized reading of scans was done by the same radiologist, or these things can be done. And similarly, you can use the patients as their own control by doing a sequential study or by doing crossover studies. And then there are some adaptive designs which have been described. For example, before you start a trial, you have to decide if the effect size I observe in the first 10 patients is so much, I will reduce the total number of patients by so many. So those are the adaptive styles which are decided, provided you have decided on these things before starting the trial. So you can change the number of patients required midway if the effect size is very good. So you can stop early if the treatment is working very well, if the certain amount of effect size is reduced. And similarly, you can drop the ineffective doses early if required. And these are some of the strategies that they are recommending for rare diseases where large number of patients are not available.
I think, thank you, Dr. Anand. Dr. Grish, your question to whom?
Sir, my question to Anand sir. Sir, what is the current stance of validation study in current scenario? And what we are feeling a problem, most of the times ethical committee does not give clearance for interventional novel studies. And because if you are going for new drug trial, then they are, no, we cannot give that. And whenever we are doing any validation study, it could not be published because the reviewers comment, the editors comment, this study already done. What more you are going to validate? But regionally, it can be different. So what is your uh, consensus recommendation, sir? What is your recommendation, sir? In which way we should proceed?
My personal feeling is that validation studies do have a role to play. If one randomized control trial has shown a particular result, or one particular observational study has shown a result in one particular regional area, this needs to be validated in other areas as well. But there are some subjects where the reaction of human beings is going to be very common, and those things
Yes,
probably will
yes.
not be controlled in this. And validation studies, I think, can be done if there have been very few validation studies done.
Okay, Dr. Nalini, second round, and Dr. Anjana followed.
So I just want to add a comment to Dr. Pati's question. I think if you have a study that is done in Western population and you want to validate it within Indian population, then I think you could make a case or a hypothesis that how the genetics or something is altered, and then you can do it. Interventional studies obviously are hard because there is a risk involved with the interventional studies. And there, I think, if you have a good data safety monitoring board, then you can probably get through your local IRBs. Uh, I think they're still doable. That should not deter you from doing them. And I agree, just doing a study just for doing sake, it's what we call a Me Too study. It's not going to contribute anything. So I think that's a question that every person should answer before they invest more time into it. Dr. Anand, off late, when I was a fellow and resident 20 years ago, we always were frustrated. We were disappointed that the study was negative and that would go to the graveyard. But I see that the journals now have been more than welcome to accept negative studies. I know Dr. Usha Datta is the editor for the IJG. Is that a change now in the editorial, the editor's playbook of accepting negative studies? Because negative studies are very valuable studies, as some of the studies have highlighted. Otherwise, we'll be repeating the same studies again and again.
I quite agree with you that negative studies are important. But the important thing is that some journals still carry a publication bias and they like to study, they like to publish significant results. But it is important that the author also, when he submits such studies, he emphasizes or he or she emphasizes on the rigor and validity of the study and mentions that he has used the highest methodological excellence. He is demonstrate that there is adequate power to the study and use confidence intervals to mention that. And these are the studies, when you highlight that it is methodologically very strong study, most journals will be willing to accept it. A neutral, descriptive, and a keyword, the title also should be such that it should not show that it is a negative study. For example, a randomized trial investigating the effects of treatment X on outcome Y. This is all that you need to say in the title. And similarly, share the robust conclusion that the intervention did not provide statistically significant benefit under the reported conditions. And in discussion also, you can say that lack of effect might be due to specific subpopulation response, metabolic differences, or known heterogeneity of GI diseases, which will prompt further studies on that particular later. You should not say that my data has shown that this has got no effect, and possibly more studies should be done to see whether it is correct or not correct.
So how do you write it is also very important.
How do you write it is very important.
Doctor, thank you, Dr. Anand. Dr. Anjana, your
And you
questions or you
time
want
up.
comment?
A quick question. I'm going back to the previous one, ma'am. Are there any courses that people can do to learn short stats easily?
Harvard conducts a course. I did my training at McMaster University, Canada. They also have training courses which are on specific aspects, so people can enroll. Usually, it's one aspect like regression was 6 weeks course. So it is not just a 2-day course. So there are small self-help books on biostatistics. There are online videos which they can do, and now SPSS also has tutorials and online YouTube versions. So suppose you just get stuck how to do a regression analysis, you can just log into any of these online videos. So there are several available. I think that would be my short answer.
And just to add, maybe the CMC Vellore has a really good course. So, and they have it's an in-person one, of course. It's not, they have shorter online ones, but this 10-day course or 15-day course, it's actually winter they have. Now it must be around this time. So that's a really good one for people.
Dr. Anjana, the Tamil Nadu Dr. MGR Medical University also.
MGR Medical University has
you
a
can
good set
log
of
on to
courses.
that and also.
Yeah,
Now,
yeah, that's the
now
other
we
one.
have only 6 minutes. This is my time now. Dr. Usha, now before we wind up, we have something very lighter sense we want to do. Anjana, how did you feel among gastroenterologists yourself?
I was completely overwhelmed, not just by the gastroenterology bit, but the whole science and the speakers. My God, outstanding. I'm so happy to be here. I learned a lot.
Yeah. What was the turning point in your life when you get into research?
For research,
Anjana.
I wrote my first paper in 11th grade. So my dad had everything to do with that. It was an LP little a. So I wrote my first paper in 11th grade.
Yours is hereditary.
And a lot of environmental fathery kind of environment. Yeah.
That is very important tone. What motivated you, Dr. Anand, to get into kind of, okay, we should do some clinical research? I want very brief answers. I have some 10, 20 questions to ask. Everyone will be different questions.
Briefest answer is I enjoyed it, so I did it.
Enjoyed it, you did it. Usha, how long did you take to get to this level of understanding of research?
It's been a long journey. Even during my undergraduate days, we were introduced to biostatistics because in AIMS they had biostatistics as a part of the curriculum. And then after that, during MD, I learned Harvard graphics and I learned.
How long? The question is, how long did you take?
Uh,
2 years, 3?
Hold, I took about 2-3 years. And after that, since then, it has been a steady learning.
Over 2-3 years. And Nalini, you are in US now. You see a overall clinician in India and USA. So what is the level of competency of clinical research? So where do we need to put more efforts?
I think in the last 20 years, things have changed a lot. I think the quality of research, the publications have significantly improved. I think our problem has traditionally been the loss to follow-up because people come from different areas and I think the one thing that Dr. Anand probably mentioned, I think, is the ethics of conducting the study, the ethics of data reporting. These are critical because once you publish data that are not, people have questions about the ethics of how it was done or the validity of the follow-ups, then you lose the credibility, and that becomes a big issue. But I think I have to say that I'm pleasantly surprised, and every year the quality of the papers that are published has significantly improved, and I think we've come a long way.
Trend, you are very happy. Haribhakti,
Yeah.
how much you are able to spend time in academic circle for writing papers and all that? You are the HOD in the medical college in.
Actually, I am in from the beginning itself. I was in the institution in the earlier at LTM Medical College, Sion, Mumbai. There I used to do a lot of paper writing, but in between we didn't. When I joined SCB Medical College, we did not have a DM course, so whole clinical work were with us.
You get
So
less
after
time to do that, huh?
yes, now we have DM course since 2010 and we are having good time and now we have more faculties, so the treatment aspect and the academic work are going in hand
Okay.
in.
Now the question to all of you, how do you find time? In 3 words you have to tell. Anjana, for the
And
research
time to
work.
do research. It's my passion.
No. When do you find time?
Oh, it's integrated into my life. That's all.
So in
I
the early
find time
morning or
because
late night, late evening, you get into
so usually on the weekends because I'm not seeing patients, on a Saturday or
So
Sunday.
you have a protected time in the weekend. That's what I wanted.
Around
Anand, how do
weekends.
you find time to do kind of clinical research? Because you are a clinician too. So how do you?
Clinical
Anjana says
research,
protected time the weekend. What
we have
about you?
we have a very good team with us, and we usually sit together. We have a lunch meeting on every Thursday in which we sit together and plan what should be done. And we distribute the duties to everyone as to who should do what. And we take suggestions from everyone as to
So
what.
every Thursday lunchtime, every Thursday. So today
Yes,
you had that.
yes.
Okay. Nalini, you are a very busy clinician. You are an associate director or something. Where do you find time? How do you find time?
It's called weekends and nights.
So again, you follow, the same like Anjana. Usha, you are very busy in the apex of the PGI Chandigarh, you HOD. I know you look tired, but how do you find?
After everybody leaves the department, that is my
Okay.
protected time. Or after I finish things at home from 11 o'clock at night till 2 o'clock.
So the
Not
moral of the story is where you find time is when others are relaxing or sleeping, you get time to do that. This is an extra burden if you think so. If it's an extra pleasure, if you think so, that you need to do the work. What is the non-medical book you have read recently, Anjana?
Wheel of Time. It's a
Do
full fiction fantasy thing.
what about
Yeah.
Anand? You write books, I know that, but which non-medical book you have read recently? He has written a beautiful book, Anand. You must, you must read it. Okay, Anand.
I
What?
recently read his Untethered Soul.
Okay.
At my
Untethered
age,
soul, huh?
at
The
my
name
age,
itself
I get
sounding very weird, huh?
oh, at my age, I get interested in more philosophy
You mean
and
the young age you are telling, or
spirituality. Yes, very
young
young
age?
age.
Young age. What about Nalini? What non-medical?
I don't remember the name of the book. I just bought it at the airport yesterday. It's a #1 bookseller. It's some kind of Indian
Fiction.
mythology book. Maybe other
Oh,
people can
I
try
know
it.
that you are interested in mythology and
Yeah.
you know every character in Mahabharata and Ramayana. I know that. Usha, what is a non-medical book? If you ever find time.
Vedanta by Partha Sarathi.
Oh, you are very. Hari, you get time to read non-medical books?
Uh, go through Gita sometime.
Okay,
Gita
Gita.
is my favorite
Okay,
non-medical
brief
book.
penultimate question. Who is your hero in life, Dr. Anjana, apart from your dad?
He has been my hero all my life.
No,
So
no, that's what I
I
said,
don't.
apart from your dad. Apart from.
Um, I'm very inspired by Dr. Shanta of Cancer Institute.
Okay. What about who's your hero, Anand?
I'm working with Dr. Subratacharya,
Ah.
and I find certain qualities that he has are just superhuman.
Oh,
And
really?
yes,
Very good.
definitely.
I know him so well, but I did not know that superhuman quality.
He,
Very good.
he has been
Fantastic.
he has been helping every person who approached him,
Oh,
irrespective of whether he knew him or not.
oh, very good. And I is a very great inspiration to me. I will talk to Subrat today itself. And what about Nalini? Who is your hero?
You're one among them, TS.
Who?
You're one among
You.
them, but yeah, there are a lot of people I've learned from in life. It's hard to say one person. Few people have molded my career, but I always look up to Nagi and feel like one day, if I can live one day like him, managing everything. So,
Okay. Usha, who is your hero? Apart from your dad and mom and what or maybe they other not the family circle, other side.
B, I like to pick up some nectar from everybody. So Dr. Anand has also been my hero. I've learned so much from him. But Dr. Rakesh Tandon was my mentor. Dr. Acharya was my mentor. And I'm
Okay.
by Abdul Kalam in his book.
Okay, other one is Abdul Kalam. Hari, who is your hero? And don't say your spouse or
Ramchandra,
anything.
Ram is my hero.
Oh, you mean a mythological character.
Yes.
Okay. The last question is who is your favorite star? Anjana?
Star as in like movie star?
Anyone? Movie, sports, or anything? Just
Okay, I like Sachin Tendulkar.
okay. Anandji?
My star is the Prime Minister that we have today.
Oh, fantastic. I think adorable. And Nalini?
I don't know. I don't adore anyone.
As a star, you don't adore anyone. I thought you were the Christopher, what is that football player? And what about you, star? Maybe music also, or it may be in the sports and other thing.
I like MS Subbalakshmi.
MS Blitz. I mean, you can't forget that song, I think. Katrinile Varum Geetham. Huh? Okay, Hari, who is your star?
Lata Mangeshkar.
Okay, I think we have come to the end of it. It's 9 p.m. and we had a wonderful two back-to-back lectures. Anand was fantastic slides. I love to uh, possess these slides and I'm glad that you have sent the slides to us and we enjoyed it thoroughly and you simplified it. Usha, despite your busy schedule, you came on time after that and it's a very difficult task. See how to design the study and how to analyze the data. It is not, you can't learn it in one day. It is fantastic. We enjoyed it thoroughly, and we have able moderators, Dr. Nalini Guda, who is they just traveled from Amritsar, and he, for the love and passion, he came to ACG webinars. And Anjana, you're so sweet, and you are moderating so well and balancing that. And Hari and Greece from Bhubaneswar. And
Thank you,
thank you
sir.
very much for this
Thank
wonderful.
you
Thank
for
you,
this
sir.
This is our
wonderful
38th.
meeting.
This is the
Namaskar.
38th
Namaskar,
webinar,
sir.
ACG Endas, and next will be 29th of January. Thank you.
Okay, sir.
Till that
Okay.
time,
Thank
I
you,
sign
sir.
off,
you.
Dr. TS.
Thank you.
Thank you.
Namaskar, sir.
Thank
And
you.
Happy New Year.